Greetings, my little triglets. Today we are doing section 3.7, and this is the last section that we're going to do, so you know what that means. All right, today we're going to talk about several different formulas and how to use them. And the first one is direct variation. I know you learned this somewhere along in your math career. The formula is y equals kx, and how we read that is y varies directly as x, or we can say y is directly proportional to x. Okay, so those are two different ways to say the same thing. The k is a constant. We call it the constant of variation, or we can call it the constant of proportionality. That's a long word. Okay, proportionality. It's basically you can set a proportion up if you want to solve some of these. All right, let's do an example here. Let's say the volume of blood in your body varies directly as your body weight. Body weight. Okay, so as we read this, it's just like saying y varies directly as x. So volume of blood is the y. Wait, let me back up here. I want to do that in red because blood is red. So y varies directly as x. So x is your body weight. So let's try a problem here. If you weigh 160 pounds, you should have about 5 quarts of blood in you. Okay, so what we need to do is figure out, if I have y equals kx, figure out what the constant of variation is, which means how are these two numbers related? How are they in proportion? How do they change the same way every time? So if I have, I can set up a proportion, or I can figure out my k first. So let's figure out k. So let's plug in what we have. Y is the volume of blood, so we have 5 quarts of blood. K we don't know. X is your body weight, which we said was 160. So divide by 160, and on my handy dandy calculator, I get that to be 0.03125. So that's the constant of proportionality, or constant of variation. So now you can put in any weight that you want. So if I want to know the amount of blood, that's our y, then I take 0.03125 and put in any weight that you want. Let's put in 250. Okay, then you can see how many quarts of blood are in a person who weighs 250 pounds. And that's very important to know those things, you know, if you're working in an emergency room or, you know, any kind of hospital setting, surgery, they have to know how much blood, or even if you're giving blood, maybe that's why you can't give blood if you're under 110 pounds, because then you won't have enough in your body, because you don't start out with enough as it is. Okay, on the same track here, you can also have varies directly as a square of something else. For example, you might have y equals kx to the n. Okay, you solve it the same way, but they would say it varies directly as the square of, you know, whatever x is. So you just got to make sure you put a 2 in and square the number that they give you. So if they say, you know, if the square of the distance, you have to make sure if your distance is 10, you square it, you're really putting in 100 for that. All right, I'm going to write down some other formulas that you need. We're not going to do problems with all these because a lot of them are very self-explanatory. The inverse variation equation is y equals k divided by x rather than multiplied by x, but it's treated the same way. And then we also have joint variation, and that actually, we're going to use the force model for that. So F equals, now you might know this from physics, m1 m2 over d squared. Okay, now what that means, the F stands for the force between the two masses, or the two bodies, either way, and m1 and m2 are the bodies, the masses. G is gravity, and that's actually going to be a constant. And then d is the distance between the masses. Okay, so just have those in your notes and have them at the ready when we do problems tomorrow in class. Okay, it's a short one. Ta-ta for now. TTFN. Trig is love.